Alright, so how do we do this? How do you find the probability that you will get more than a 700 on the SAT? What is our formula? The value, so x minus the mean over what? Standard deviation. So, if our value is 700, our mean was 500, and the standard deviation is 100, this is going to give us a what? It gives us a z-score, right? So, what is the z-score? Well, that is 200 over 100, so that is equal to 2. Now, you've got to think about this though. When we look at our z-score table, that gives us the probability of everything to the left. If we're looking at more than 700, that's going to be to the right of 700. So we know that we are going to have to do what? 1 minus our probability, okay? Because think of it like this, you have to find the complement of everything to the left, right? Because you're looking for the right. So, if this was equal to 0.9772, we would say 1 minus 0.9772, and that would equal 0.028. 228. So, remember, if it's more than, you're going to have to take 1 minus that. You're going to find the complement of that. Is that what everybody got? Everybody got that for the more than? For A. Alright? Now, this says between 440 and 560. Now, if it was me, I would go ahead and start with the 560, because I know that's the number that I'm going to start with. And I'm going to subtract my probability of 440 from it. So, if I did that, let's see here, we would say 560 minus 500 over 100. That looks like 700, I don't like that. And that is 60 over 100, which would be 0.6. And if you go to the Z chart, okay, I'll go ahead and erase this stuff. If I go to the Z chart and find that, it will have 0.7257. So the probability is 0.7257. Alright? Now I'm going to hop up here and do 440. The value minus the mean over the standard deviation. And that is what? Negative 60 over 100. So what's that going to be? Well, if you look at your Z chart, that's negative 0.6. That would be 0.2743. Now we're looking at in between it, in between those two values. So we're going to take this value, subtract that value, and that gives us What? The exact same thing, huh? Is that right? Oh, that's not right. What is that? 0.7257 minus 0.2743. There we go. 0.4514. Everybody got that? Alright. Now, for 2, you should be able to do the exact same thing. It's between, the only difference is for B, it's less than 350. Okay? Which is perfect because our z-score chart tells us the probability of everything less than that z-score. So all we have to do is find that z-score, find the probability, and we're done. Okay? So let's do B right quick for number 2. That is 350 minus, let's find the mean. The mean was 514 here. Standard deviation is 117. So 350 minus 514 is a negative 164 over 117. And that is equal to a z-score of negative 1.40. Now if you go look at your z-chart, that should tell you the probability is 0.081. Now let's think about that. If we think about that in our graph, okay, this is the mean. Negative 1.4 is going to be way down here, right? Almost to negative 2. So we only have about 8% down here. And that's what that's saying. Everything to the left of that's only about 8% of your total values. Right? Alright, y'all do A right quick. And, or tell me what you got for y'all that done A. What did you get for A? You got a negative percentage? What did anybody else get? Okay, good. I was about to say, you shouldn't come up with a negative percentage or a negative proportion. Alright. Anybody not understand what we're doing here? We're taking the value, taking the mean from that value, divided by standard deviation to find our actual probability or our actual proportion of that value. Alright, so let's go to page 2 then. And this is airline call centers. Here we're talking about probabilities. It says when a call center receives an airline, when a call is received at an airline's call center, the probability that it comes from abroad is 0.32, and the probability that it is to make a change to an existing reservation is 3800. A says, suppose that you are told that the probability that a call is both from abroad and is to make a change to an existing reservation is 1500. Calculate the probability that a randomly selected call is either from abroad or is to make a change to an existing reservation. So, whenever we're talking about either or, right? Okay, let's label these. let's call it, what do you want to call it? A for abroad, and we'll call it R for reservation. Okay? So we're trying to find the probability of A or R. So you should know from your quiz, if you didn't do well on your quiz, or if you didn't get this on your quiz, you need to go back and look at it. Okay? Go look at your quiz from topic A, and this will tell you that A or R is equal to the probability of A plus the probability of R minus the probability of A and E. Now, what does that look like as far as a Venn diagram goes? Well, we did our Venn diagram. If this is A and this is E, we're going to take A plus E, but then we've got to subtract, R. Let me change that. R. But we've got to subtract this portion, because we're looking for A or R. Yeah. Yes. So you need to subtract that from 0.32. Okay? So, let's look at it. If A, remember how I always take A and pull it out, R and pull it out. A was 0.32, R is 0.38, and then it told us that the center part here is 0.15. So now I'm going to have to subtract that from 0.32, because that's included in that. So when you do that, you should get 0.17, and over here you would get 0.23. Yeah. Now, what is going to be your answer? Well, technically, you don't even have to do that here and here. Right? That's just how you would do it if you want to look at it in a Venn diagram. We already know our values. A and R is 0.32 plus 0.38 minus 0.15. There's all of our values that we need to know. So, when you do that, you get the answer for A or R to be 0.55. So the probability of them calling to talk about an existing reservation and that the call is abroad is over 50% chance that it's one or the other. Okay? I just said if you want to look at it in the scheme of a Venn diagram, what does it look like? Okay? And then it says, calculate the probability that a randomly selected call is either from, okay, that's what we did. Now, number 4. Suppose now that you are not given the information in part A, but you are told that the events of the call is from abroad and the call to make a change to an existing reservation are independent. Now, that makes sense, right? If you call from abroad, does that mean you have to make a change to your reservation? Does it mean that you can't make a change to your reservation? No, because you calling from abroad doesn't affect whether you're calling about a reservation or not, right? So, this says, what is the probability that a randomly selected call is either from abroad or to make a change to an existing reservation. Okay? We know that for them to be independent, that means what? That when we can multiply those two together, right? And that gives us our number. Okay? That gives us this number right here. So let's do that. Suppose that we were not given this information. So let's get rid of that. And now, if it's independent, we can calculate the independent event as A times R, probability of A times probability of R, and that's going to give us 0.1216. 0.32 times 0.38, yes. Now, that is now going to be here. So let's call it 0.12. Okay? In the previous problem, they gave us that information. But here they say it's independent, you figure it out, and then solve for the probability. This says, what is the probability that a randomly selected call is either or? So it's the same thing, right? It's going to be P of A or R. But it's going to be with this term. So we would just say 0.32 plus 0.38 minus 0.12. So that should equal let me just do it. 0.32 plus 0.38 minus 0.12 be 0.58. And we know that. If you look at those two, it's only 3 less, so it should be a 3% probability more. And there you go. There it is. Okay, everybody good? Alright, so that's kind of the last part. That's topic 2, or topic B of these first two. Topic B. Now we're going to get into the probabilities. We're kind of going through the review in reverse. Okay? So let's look at the probabilities here. A golfer will play 2 holes of a course. Suppose that each hole of player will score 3, 4, 5, 6, or 7. Now these 5 scores being equally likely, find the probability and explain how the answer was determined that the player's total scores for the 2 holes will be, 14. You've got 2 holes here. You can only score 3, 4, 5, 6, or 7. How can we get a combination of 2 holes to equal 14? 7 plus 7, right? Now, what's the odds of getting a 7? 1/5. So, we would have the probability of getting a 7 plus the probability of getting a 7. Actually, nope, sorry, stop. That is not correct. It's times the probability of getting a 7. So they're independent events, right? So that would be 1/5 times 1/5. And that would give you 1/25, which is equal to 0.04. You got about a 4% chance of getting a 14 on 2 consecutive holes. Okay? Now what about a 12? What are the combinations you can get for it to equal a 12 on 2 holes? Alright? Probability of a 6 and a 6. What else? 7 and 5. And what else? got a 7 and a 5 on the next hole, could you get or I mean, not on the next hole, but could you also have gotten 5 on the first hole and 7 on the second hole? Yeah, I just reversed it. So we'd have the probability of a 5 times probability of a 7, okay? Now, does it really matter if it's a 6 or a 5 or a 7? No, because it said we were equally likely to get those. So we would say 1/5 times 1/5 plus 1/5 times 1/5 plus 1/5 times 1/5. And we already know what 1/5 times 1/5 is. That's 0.04. So that's going to be what each one of these are, which is going to equal 0.12. So B is 0.12. You got about a 12% chance of getting a 12. Okay? You got a 4% chance of getting a 14. You got a 12% chance of getting a 12. Okay? Page 6. It says, of the light bulbs available at a store, 42% fluorescent, 32% are labeled as lifelong, and 12 are fluorescent and lifelong. A light bulb will be selected at random from light bulbs at this store. Rounding your answer to the nearest thousandth where necessary, find the probability that the selected light bulb is not fluorescent. Probability that it is not fluorescent is called the what? What? The complement. So it's a fluorescent complement, right? So we would write that as, let's call it fluorescent as L. So that would be 1 minus, what was the percentage of fluorescent? 0.42, which is going to be 0.58 or 58%. Right? Everybody good? All right. What about the selected light bulb is fluorescent given that it is labeled as lifelong? So, remember how we write these? We would say the probability of L given, can I just call it L for lifelong? Okay. What's going to be in our denominator? Lifelong. Whatever is given is your denominator. So what is given is that it is a lifelong, which is 0.23. Lifelong was labeled, or they were 23%. Now, what are we looking at for the top? What's going to be on top? Top is going to be fluorescent and lifelong. Okay, because it's got to be lifelong. We are given that it is lifelong, right? But we're looking at the fluorescent in that group. Okay? And it tells us that 12% are fluorescent and lifelong. So we're going to put that on top. 0.12, that's about half, right? 0.12 divided by 0.23 is 52%. 0.522. Yeah? Okay, we would have L plus L. It gave us what fluorescent and lifelong was, so we're just going to use that. it told us what it was. So that's when we use it. Claire? Yes. Okay. So we would call this 52.2%. Okay. B says, are the events fluorescent and lifelong independent? What would it mean that they have, if they were independent, what would that mean? Say it again. Okay. So she says the probability of L times L is equal to the probability of F plus L. Is that true? Well, 42% times 23% is equal to 0.0966. So what is the probability of fluorescent plus lifelong? That's 65%. So that's not true. So no, they are not independent. Alright, number 7 says, when a person is selected at random from a very large population, the probability that the selected person is right-handed is 82%. If 3 people are selected at random, what is the probability that they are right-handed? Well, since it doesn't matter about the previous person, we just multiply these together, right? So, if you multiply those together, you would get about 0.551. Alright. Is that it? Is there another one? Actually, I think I cut it off. There's one more question, right? The next one says, what is the probability that none of them are right-handed? Well, that would just be the complement that they are right-handed, right? Times each other. So that would be 0.18 times 0.18 times 0.18, which would equal about 0.0001.